Okay, moving on to the last segment of our lesson. Finding the area between two shapes. Now, the key to finding the area between two shapes is this. The shaded area, the space between, is always going to equal the outer shape minus the inner shape. Okay, if I have the outer shape and then I subtract the inner shape, that should, sort of like cutting it out with scissors, that should leave the outline. So in this case, the outer shape is the circle. Okay, so it's the circle minus, and the inner shape is the square. So this is my strategy to do the circle minus the square. Now keep in mind the formula. So for a circle, the area is pi r squared, so I'll be doing that. For a square, the area is base times height, so I will be doing that. Now the circle part is easy because all we need is a radius, and there it is. So this is going to be pi times 9 squared. So we're all set up for that. Now, unfortunately, the square is going to take a little bit more work. We have this 9, but that's not the base, that's not the height. So we're going to have to do a little bit more to find the base and the height. And here's what we need to do. In a previous unit, we learned about 45, 45, 90 triangles and the special relationships that they have. And we learned that if we have a 45, 45, 90 triangle, whatever the sides are, or which are the legs of this right triangle, the hypotenuse would be leg times radical 2. So if this was x, this would be x, always isosceles, and the hypotenuse would be x radical 2. Okay, focus on this x radical 2 with me. Okay, focus on that, x radical 2 for the hypotenuse. Now, I'm mentioning that because anytime you take a square and you split it, you are going to get a 45, 45, 90 triangle. So as I take this and I look at the diagonal of the square, I'm hoping that you will see that what I have here is a 45, 45, 90 triangle. Okay, because this is 45 degrees, and so is this. Now, remember the pattern from the formula sheet here. It goes like this. We need to know what the sides are, so let's call them x. We know they're the same. Well, that means that the hypotenuse here is going to be x radical 2. Okay? All right, but we know that the hypotenuse is 18. How did I know that? Because I see the 9, okay, and the 9 is a radius. So if I go the whole way across, that'll be another 9 for a total of 18. So I just did 9 times 2. So these two must be equal to each other. Okay, the x radical 2 is an expression for the hypotenuse. 18 is the known length of the hypotenuse. So off to the side someplace, all right, I will make this little equation. X radical 2 must equal 18. So then I can just divide both sides by radical 2 to get x by itself. And it turns out that x is 9 radical 2. Okay, that means these sides of the square are 9 radical 2. Okay, that means this is 9 radical 2 and this is 9 radical 2. Well, guess what? Now we know the base and the height. They're both 9 radical 2. So back to the problem, I wanted to do base times height to find the area of the square. And now I know it. So that's 9 radical 2 times 9 radical 2. Okay, let's simplify this as much as possible. So 9 squared is 81, so that's 81 pi minus 9 9 radical 2 times 9 radical 2. Let's see if the calculator will do this properly, because I don't want any decimals yet. So 9 radical 2 times 9 radical 2. $162. Look at that. Okay, now that would be the exact answer. It will not simplify any further. This has a pi, this doesn't. I cannot subtract 81 minus 162. That would give me a negative number anyway. We are talking about area, and this was feet. So I could put units on here, feet squared. But anyway, maybe I'll stick it over here. That is the exact answer. But often you really want a decimal. So let's follow through and get a decimal. So 81 pi minus 162. 81 pi minus 162. And we get 92.47. Square feet. Okay, so we have the exact answer and our decimal approximation. That is how you do a shape inside of a shape. Okay, it's always going to be the to find the space between, you will always find the area of the outer shape and subtract the area of the inner shape. Alright, so watch out for that. Finally, number 6. Again, this is the space between two shapes. Number 6 is a little bit simpler since they are both circles, but I'm still going to be careful. So if I want that shaded area, okay, this shaded area, like we mentioned before, should equal the outer shape minus the inner shape. Alright? So in this case, they're both circles. So we're going to find the area of the big circle, and we're going to subtract the area of the small circle. By the way, see how I make these little diagrams? And I set it up, and I do, if I'm going to do circle minus square, I make a circle minus a square with symbols, pictures, sort of a picture equation. You should always do that, just like me. So anyway, in both cases, since they're both circles, the area is going to be pi r squared. Alright, not a lot of room for that one, but pi r squared. So, let's do it. Now, for the big circle, I have to be very careful about my radius. Most kids can see pretty easily that the radius of the small circle is 8. Okay, since the diameter is 16, the radius here is 8. So when it comes time to do the small circle, and we have to do pi times 8 squared, they get that part right. But then some kids will mistakenly think that the 7 is somehow the radius of the big circle, and they'll want to put pi 7 squared next. No, 7 is not a radius. It does not go all the way across. But what we can do is draw a radius of the small circle right here to help us see what's going on. And if we see that this is 8, then that might help us see that if we want the total radius of the circle, we're going to have to add these together. Okay, so this is 8, and then that's 7, so that's a total of 15. So the radius of the big circle is 15, not 7. So this will be pi times 15 squared will be the area of the big circle. So 15 squared is 225. So that'll be 225 pi. 8 squared is 64. So that'll be minus 64 pi. Now remember here where we had to stop for the exact answer? That was because these were not like terms. This one had a pi, this one didn't. Notice that both of these have a pi. Okay, so these are like terms. So I can combine these. Your calculator probably even knows this. So 225 pi minus 64 pi, that's 161 pi, like terms. So our exact answer will be 161 pi square meters. Okay, so that is our exact answer. Of course, then we can go ahead and get a decimal approximation using the toggle button. So 505.79 would have to round up to 80. So 505.80. Okay, so that is how you find the area between two shapes. You just take the area of the outer shape and subtract the area of the inner shape. Use your picture equations to help you keep your work organized. All right, I hope this lesson has been helpful to you. If it has helped you in any way, please give me a thumbs up. Hit that like button for me, and I really appreciate it. I will see you on the next video.